Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your water hardness testing by a complexometric determination of calcium. So what we have to do, we have to determine the water hardness. We have to determine this water hardness, and along with it, we have to determine the calcium. Now, water hardness is what? Water hardness means that the amount of calcium and magnesium present into a water. Magnesium present into a water. It defined as a water hardness. So what we have to do, we use a two method for the determination of the water hardness. Here we are using the first method, that is your EDTA tetrametric method for a testing hardness of water. What is this EDTA means? That see, EDTA are what? EDTA is ethylene diamine tetraacetic acid. Okay, this ethylene diamine tetraacetic acid are used to determine are used as a chelating agent, and it is used for a heavy metal toxicity. Okay, it is what? It is used as a chelating agent. Okay, and it also used as a determination. It is used for a heavy metal. It is used for a heavy metals. Okay, for the determination of this heavy metal. It is first introduced or first detected in 1930. Okay, now what we have to do, we use this EDTA tetrametric method for the determination of the hardness into a water. Now see the introduction part. This ethylene diamine tetraacetic acid is what? They are the complex of numeral mineral ion. Okay, like your calcium and magnesium. Okay, they are the combination of numerous minerals ion, which also include this calcium and magnesium, and the reaction is used to determine that the amount of this minerals present into a sample by a complex metric titration. Okay, what we have to do, we use a complex metric titration method so that we determine that the how much amount of these minerals are present into our sample. Now the end point of the titration will decide the which type of indicator we use and which type of minerals are present, and according to them the colors are changed. Okay, the calamigite and the Eurochrome black, that is also called TEBT, are the indicator which turn blue to pink, and this is known as a endpoint, and which indicate that they have a complex of calcium and magnesium. Now see, endpoint in a titration are detected using a indicator that change color when they complex with minerals ion. Okay, calamigite and the Eurochrome black tea, that is called a EBT, are such indicator that change from blue to pink when they are complex with the calcium and magnesium. Okay, now in the titration of mineral which contains solution with EDTA, the solution turn from pink to blue at the point with either indicator. Okay, so when we titrate this, if the minerals contain this EDTA solution, then the solution are turned from pink to blue. Okay, now the pH also affect the complexometry of the EDTA titration in several way and must be carefully controlled. Okay, this pH are very important when we find the titration, when we do the titration method for the finding of this hardness of the water. So we have also monitor this, and they have a major application. EDTA titration technique is used to test the hardness of the water, for which the method described is an official one, and that method are called what? Examination of water and wastewater method. 2340C AOAC method 920196. Okay, this is the method that we use for the determination of the hardness of water with the help of this EDTA. Now, hardness of water can also be tested by more rapid test strip method. Okay, the second method is what? The second method is a rapid test strip method. Okay, so we are discuss both the method. The first one is your EDTA method and the second one is your rapid test strip method. But in this class, we are only focus on the EDTA method for the determination of the hardness. Okay, now these strips are available from a various companies, and the strip contain EDTA and an indicator chemical to cause a color change when the calcium and magnesium in water react with the EDTA. This is what it is, simply a strip in which the EDTA chemicals are present, and it also contains some indicators chemical which can change the color of the strip when it dip into a water which contains this calcium and magnesium ion. So here we are not talking about the rapid test strip method. We are only focus on this EDTA method. Now the object is what? We have to determine the hardness of the method by this EDTA titration method and with a contact test strip. So this will not be discussed today. Here we are only discuss about the determination of the hardness of water by a EDTA titration method. Okay. Now the next one is your principle of this. So what is the principle of this? We all know that this EDTA form a stable 1:1 complex with the calcium or magnesium at pH 10. Okay, we all know that when the pH is 10, then this EDTA, that is your ethylene diamine tetraacetic acid, form a complex with the calcium and magnesium. And when we use these metal ion indicator, that is your calmagite and the Eurochrome black tea, that is also called EBT, then the pink color are formed when complex with the metal ion, but blue color are formed when no metal ions are complex to them. If the metal ions present, then it form a complex with the EDTA, then it form a pink color when we use the indicator, that is your Eurochrome black tea and calamigdite, but it not form any complex when the metal ions are not present, then the color of the solution will turn blue. Okay, and these indicator will also bind some metal ion which are not strong as such that your EDTA are strong. Now when we added this indicator into a solution in which the metal ions present, then the solution become pinks. And when we titrate this EDTA to the minerals containing sample, then the minerals preferably complex with the EDTA and leave these indicator without medical ion in the complex. Okay, if we uses the enough EDTA and titrated to the complex with all the metal ion which are present in the the indicator appear blue. This blue color is the endpoint of the titration, and the volume of the concentration of the EDTA in the titration are used to calculate the concentration of calcium in the sample, which is expressed as milligram calcium carbonate per liter. Okay, milligram calcium carbonate per liter. Now the next one is your what? Stereochemistry of the reaction is 1 ml of calcium complexy with 1 mole of EDTA. Now see what is written in the slide. Ethylene diamino tetraacetic acid, that is also called the EDTA, form a stable 1:1 complex with the calcium or magnesium at pH 10. The metal ion indicator calamigdite and Eurochrome black tea, that is also called EBT, are pink when complex to metal ion, but blue when no metal ions are complex to them. The indicator bind to metal ion which are less strongly than does EDTA, and when the indicator is added to a solution containing metal ion, the solution become pink. Okay, when EDTA is added as a titrate to the mineral containing sample, metal ion preferentially complex with the EDTA, leaving the indicator without a metal ion to a complex. When enough EDTA has been titrated to complex with all the metal ion present, the indicator appear blue. This below color is the end point of the titration, the volume and the concentration of the EDTA in the titration are used to calculate the concentration of the calcium in the sample, which is expressed as milligram calcium carbonate per liter. Stereochemistry of the reaction is 1 mole of calcium complexy with 1 mole of EDTA. Now the next one is your chemical used for this experiment. We are using ammonium chloride, ammonium hydroxide, calcium carbonate. Okay, and ammonium chloride case number 1214125-0209, ammonium hydroxide that is 1336-21-6, calcium carbonate that is 471-34-1, calamagide that is also called 3 hydroxy 4,6 hydroxy M toluloso naphthalene 1 sulfonic acid that is called 3147-146. Okay, the next one is your EDTA, that is your ethylene diamine tetraacetic acid and disodium salt 60-00-4. Okay, and hydrochloric acid, and it is in concentrated form, magnesium chloride hydroxide hexahydrate, magnesium sulfate heptahydrate 777647-01-0, 779-1-18-6 10034-998. Okay, and hazard related to these chemicals are what? They are harmful, they are corrosive, dangerous for the environment, they are irritant, and they are corrosive. So when we are using these chemicals, we have to take a. And the next one is your reagent preparation. Okay, so we required some reagent for performing this experiment. Now this slide is you what? This slide is for reagent preparation. So the first reagent that we required is a buffer solution. So we required a ammonium chloride. Okay, ammonium chloride, and the amount of ammonium chloride is what? 16.9 gram. And this 16.9 gram of ammonium chloride are dissolved into a ammonium hydroxide whose volume will be 143 ml. Okay, so what we have to do, we take off 143 ml of ammonium hydroxide and it will dissolve into a ammonium chloride, 16.9 gram of ammonium chloride. Then after that, what we have to do, we take 50 ml of deionized distilled water, and in deionized distilled water we dissolve this EDTA sodium salt. Okay, what should we do? Suppose that this is your beaker, and in beaker there is a 50 ml of deionized distilled water. Okay, now into it, what should we do? We dissolve 1.179 gram of EDTA sodium salt. They are called what? They are called the analytical reagent. Okay, now after that we are also take our 1780 gram of magnesium sulfate or 644 gram of magnesium chloride heptahydroxide. Now combine these two solution with mixing, and then after that we have to dilute it with a double distilled water, and the volume of the double distilled, sorry, deionized distilled water, and the amount of deionized distilled water is what? 250 ml. Now we have to store it in a stopper, Pyrex or a plastic bottle, so that we have to prevent the ammonia oxide to pick up the carbon dioxide. Okay, now disperse this buffer solution with the repipette system and discard the buffer 1 to 2 ml added to a sample failed to give a pH 10 plus minus 0.1 at the end point of the titration. So this is how we prepare the buffer solution. Now the next solution is what? This is your calcium standard solution, 1 milligram. Okay, now we required what? This is used for official method omide, and it is used for a methyl red indicator. Now what we have to do, we have to take a primary standard or a special reagent that is low in heavy metals like your alkalis and magnesium. Now what we have to do, we take a calcium CaCO3 try. Okay, at 100 degrees Celsius for 24 hours. What should we do? We dry this CaCO3 at 100 degrees Celsius for 24 hours. Then after that we take a 1 gram from it. Okay. Now after that we transfer this. Suppose that this is your ethereal flask of 500 ml. Now after drying CaCO3, we transfer 1 gram CaCO3 into a 500 ml of ethereal flask. Now after that we place a funnel into a flask and add a equal amount of concentrated H2O, so HCl and H2O, a little at a time until all the CaCO3 has dissolved. Okay, so when all the CaCO3 is dissolved, then we wash the neck of the ethereal flask with the HCl, and after that again we add deionized distilled water, and the volume of the deionized distilled water is what? 200 ml. Now after few minutes, to expel CO2, we have to cool down and adjust its pH 3.8 with the help of ammonium hydroxide, 3 molar of ammonium hydroxide or HCl. But at the same time, the ratio of the HCl and water should be 1:1. That means that if we take a 1 ml of HCl, then the H2 will also be a 1 ml. Now after that we transfer the quantitatively to 1 liter of volumetric flask and dilute to volume with deionized water. That is 1 ml is equal to 1 milligram of CaCO3. Now the next one is we require a EDTA solution whose concentration will be a 0.01 mole. For this we required a 3.723 gram of EDTA sodium salt, and this will be dissolved into a 1 liter of deionized distilled water, and it should be stored into a borosilicate glass bottle. And this is a standardized solution using the calcium standard solution as prescribed in the procedure. Now after that we required a hydrochloric acid 1:1 with water. If we take HCl 10 ml, then water should also be a 10 ml. Okay, now we have mixed it very carefully, and the water is what? Water is a deionized distilled water. Now we also required a calamigide. What should we do? We take a 0.10 gram of calamigide and it should be dissolved into a 100 ml of deionized distilled water. Then we take a 1 ml per 100 ml solution to be titrated. Put the bottle with a eyedropper. Now the next one is your hazard precaution and waste disposal. We all know that we are using the corrosive and irritated chemicals. So when we are using it, we have to take a take a care. We have to wear a glove, safety glasses, and the buffer also containing the ammonium hydroxide. So when we dispose the waste, it should be disposed as a hazardous waste, and we have and other waste we have drained out with the water rinse. And all the good laboratory practices should be practices. We have to avoid the chemical to come in contact with our skin, our clothes and all. And we have to take a care so that we in the environmental health should be maintained, and we have also followed the protocol of our institute. Now see what is written in the slide. Adhere to a normal laboratory safety procedure. Wear a gloves and safety glasses at all the time. The buffer solution which contain ammonium hydroxide should be disposed of as a hazardous waste. Other waste likely may be put down the drain using a water rinse, but follow a good laboratory practices outlined by our environmental health and safety protocol at your institution. Now the next one is the material required for this experiment. We required a burette of 25 or 50 ml. Okay, 9 ml flask of 125 ml, funnel to fill the burette, graduate cylinder of 50 ml, 3 graduated cylinder of 25 ml, graduated cylinder of larger volume may be necessary, for example 100 ml or larger. Size to be determined by trial in section 16.2 8.2. Okay, we also required a mechanical pipetter of 1000 microliter with a plastic tips. We also required a pasteurized pipette and bulb, spatula, volumetric flask of 1000 ml, volumetric pipette of 10 ml, and weighing paper board. Now the next one is the equipment we required: analytical balance, drying oven whose temperature should be reaches at 100 degrees Celsius, hot plate, and pH meter. See, pH meter we use, what we use are electronic pH meter. So electronic pH meter, so when we take a pH of any sample, we have to calibrate it. Okay, how we calibrate it, this video is already uploaded in our account. You can go and check how we calibrate this pH meter. But the calibration of the pH meter is very important before every use. Okay, now first of all, now come to the procedure part. This is your procedure part. Now for the procedure, we require a sterilization of EDTA solution, the first one. So for this, what we have to do, we have to take a 3 ml flask of 125 ml. Okay, this is your ml flask of 125 ml. In each of the ml, what we have to do, we have to put 10 ml of calcium standard solution. Calcium standard solution. Okay, in each of the flasks, like this, like this. So, okay, suppose that this is your A, B, and C. After that, what we have to do, we have to adjust its pH. Okay, adjust its pH 10.0 plus minus 0.5. Okay, with the help of the buffer. Okay, if possible, do this pH adjustment with the buffer in operating hood due to its order. Okay, now it is very necessary that we use HCl solution in adjusting the pH. Okay, when the pH is adjusted, now what we have to do, we add 1 ml of 1 ml of calamagnide in each flask, like this, and this. After that, we have to titrate the flask with the EDTA with the continuous stirring, and we do it until the reddish color is disappear. Okay, adding last few drop at 3 to 5 interval. Okay, now the color at end point is what it blue in daylight and under daylight fluorescent lamp. Okay, now color may be first appear lavender or purple, but will turn them to blue. Okay, maybe when we titrated with the EDT, then the first it will appear lavender or a purple color, but we have to titrate it until we get a blue color. Now complete titration take 5 minutes from the time of buffer addition. Now we have to record this EDTA solution volume for each titration. Okay, like so for first we do titration for A, then we do a titration for B, then we do a titration for C. For each time we record the volume of EDTA used for the titration. Now what we have to do, we here after calcium standard solution, we titration of water sample. So for this, what we have to do, we take a 25 ml of water sample. Okay, after that we add 50 ml of deionized distilled water in 125 ml of aeramial flask. Okay, after that we add a 50 ml of distilled water without dilution. Okay, now this sample again, it is prepared for a triplets. Okay, after that we adjust the pH of same, and again we describe the sorry, again we do again we adjust this pH with the help of this HCl solution and titrate with the standard EDTA solution. Okay, now slowly after that, we record the volume of EDTA solution, and we titrate with the EDTA until we get a blue color. This blue color is what it is, a end point. Okay, we are doing the same thing here. On the place of the calcium standard solution, we take a dilute 25 ml of tap water, and into it we add a 50 ml of deionized distilled water, and along with it we also add a tap distilled water of 50 ml, and this is what, this is a without dilution, and we perform it with the triplet form. Now data and calculation. After After doing the procedure, we have to follow the data and calculation. Calculate the molarity of the calcium standard solution. Now it is calculated by a gram of calcium standard solution divided by 100.09 gram of mole liter per solution, that is equal to molarity of the calcium per liter. Okay, after that what we have to do, we take a sterilization of the EDTA solution. Here the burette start, here the burette end, and here the volume titrate. Okay, then after that we put it the molarity of the calcium solution. This is for a calcium solution. This table is for the calcium solution. Now with the help of this we find out the standard and mean and the standard deviation of the calcium solution. Now after that we have to calculate the molarity of the EDTA. For this what we have to do, we all know that molarity of the calcium is equal to molarity of the EDTA. Okay, now M1V1 is equal to M2V2, that is equal to the first one is your molarity of the calcium, and this is your molarity of the volume of the calcium. This is your molarity of the EDTA and volume of the EDTA. With the help of this we find out the molarity of the EDTA solution. Now we have to put it into a table. Here the dilution, here the burette start, here the burette end, here the volume titrate, and the calcium and the gram of calcium per liter is used, and the milligram of calcium CaCO3 is used per liter. With the help of these we also find out the mean of the uh, table and the standard deviation for each one. Now the next one is your calcium content of water sample can be calculated is equal to same formula, M1V1 is equal to M2V2. Now M calcium in a sample multiply by 40 into 0.85 gram of calcium, that is equal to gram of calcium per liter. When we solve it, we get the amount. Okay, so this is all about the how we find out the calcium concentration and the hardness into a water by using a EDTA method. Thank you for watching. Please like, share and subscribe. If you have any query, just let us know in a comment box. You can also ask your query to the helpline number that are already mentioned in your slide. You can also visit our website, that is your www.itlsacademy.com. You can also follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn, and also subscribe ITLS Academy on YouTube and get our app from a Google Play. Thank you so much. If you have any query, just let us know in a comment box.